All right, 4.1. We're going to talk about angles. So an angle is measured or is determined by rotating a ray, which is half a line, about its end point. The starting position of the ray is the initial side. So that's where we start, is the initial side. And then the position after rotation is the terminal side. That's where our angle is going to end. The angle is formed in between the initial and the terminal side. So this is going to be our angle. The end point of the ray is the vertex of the angle. So the vertex comes from here. This perception of an angle fits a coordinate system in which the origin is the vertex and the initial side coincides with the positive x-axis. So our initial side starts at the x-axis here, the positive x-axis. This is where we start when it's in standard position. So the positive x-axis is where our initial side is. And then the terminal side is just where our angle ends. So this would be the angle in here. Positive angles are generated by counterclockwise rotation and negative angles by clockwise rotation. So if we start by going up in the positive direction, this would be a positive angle. If we start at the x-axis and go down, this would be a negative angle. Angles are labeled with Greek letters such as alpha, beta, and theta. Theta is probably the most common one that we'll see, but if you see this alpha or beta symbol, those are also talking about angles. And then we can also label angles with uppercase letters such as A, B, and C. Note that angles alpha and beta have the same initial and terminal sides in the pictures down here. Such angles are coterminal. So alpha starts in the positive direction, so this would be a positive angle, where beta goes down, so this would be a negative angle. So these two angles have different measures. If you look at the length of them, they're different sizes, they're different angle measures, but they are coterminal because they stop in the same spot. They have the same initial and the same terminal side. So even though they're different angles, they are coterminal. Same thing with the second one. Alpha is just this little angle here where beta goes around the whole circle and a little bit more. So beta is way bigger than alpha, but they are coterminal angles because they have the same initial and terminal side. So that is what coterminal means. So one way that we can measure angles is in radians. The measure of an angle is determined by the amount of rotation from the initial side to the terminal side. One way to measure angles is in radians. This type of measure is especially useful in calculus. You can define a radian by using the central angle of a circle whose vertex is the center of the circle. So we'll talk about like the length of a radian or the measure of it on the next page. So 1 radian is the measure of a central angle. We use this formula here. So theta is equal to S over R, where S is the arc length. So arc S. And then radius is R. And then theta has to be measured in radians when we do this formula. Now we'll talk about it a little bit more on the next few pages, but a full revolution, so all the way around the circle, is 2 pi radians. We're going to go in between radians and degrees a lot. So 1 full revolution of degrees is 360 degrees. So 360 degrees is equivalent to 2 pi radians. Before, when the SAT was on paper, I'm not really sure what it looks like when it's online now, but it used to have like a formula sheet for the math section where it had like 10 formulas on it. This was one of them. It used to tell you on the SAT 2 pi equals 360. So 2 pi, if we multiplied 2 times pi, we would get 6.28 about. So 1 full revolution around the circle is 6.28 radians. So 1 radian is about this length. Most of the time, we're just going to keep our radians in terms of pi, so it doesn't really matter. But most important thing here is to know that 2 pi is 1 full rotation around the circle. So we're also going to be talking about quadrants. So we've got 4 quadrants in our coordinate system. The positive x and y quadrant is where we start. So quadrant 1. Then we go counterclockwise around. So the one on the left top would be quadrant 2, then quadrant 3, then quadrant 4. And then because all the way around the circle would be 2 pi radians, if we were to cut that into 4 quadrants, so if we divide 2 pi by 4, each quadrant's going to have the length of pi over 2. So quadrant 1 is from 0 to pi over 2. Quadrant 2 is from pi over 2 to pi. Quadrant 3 is from pi to 3 pi over 2. And quadrant 4 is from 3 pi over 2 to 2 pi. So all the way around would be 2 pi. Each quadrant's just a quarter of that. One other thing to note here is that angles between 0 and pi over 2 are acute. So we typically would say that angles less than 90 degrees are acute. But in between 0 and pi over 2 is equivalent to 0 and 90 degrees. And then angles in between pi over 2 and pi are obtuse. So angles greater than 90 would be obtuse, but less than 180. So we said before, 2 angles are coterminal when they have the same initial and terminal sides. For instance, the angles 0 and 2 pi are coterminal, as are the angles pi over 6 and 13 pi over 6. An angle has infinitely many coterminal angles. To find coterminal angles, we can add or subtract 2 pi as many times as we want. So if I took pi over 6 and added 2 pi to it, it did the math for us, which is how it got 13 pi over 6. But if I take pi over 6 and add 2 pi and then add another 2 pi, that would give me another coterminal angle. I could just keep adding 2 pi again and again and again and again and get an infinite amount of coterminal angles. Now we can also take pi over 6 and subtract 2 pi and get another coterminal angle. So you can add 2 pi or subtract as many times as you want. So in example 1, it was done for us, but it says for the positive angle theta is 13 pi over 6, subtract 2 pi to obtain the coterminal angle. So they subtracted 2 pi and got pi over 6. Some of the questions on WebAssign will ask for a positive and negative coterminal angle. So there's more than one right answer for all of these questions when it comes to coterminal angles, because we can have an infinite amount of coterminal angles. If we were given the angle 13 pi over 6, pi over 6 would be a positive coterminal angle. How do you think I could find a negative coterminal angle? I would keep subtracting. So I would take pi over 6 and subtract 2 pi. So how would I subtract these? What do we need? Common denominator. So I can make it 2 pi over 1. And then we need a denominator of 6. So I'm going to multiply the top and the bottom by 6. Bless you. So you get 12 pi over 6. What's pi minus 12 pi? Negative 11 pi over 6. So that would be our negative coterminal angle. Most important thing here when you're finding positive and negative coterminal angles, make sure your positive one is a positive number and your negative one's going to be a negative number. So you may have to add or subtract more than once to find a positive and a negative coterminal angle. Do the same thing for the next one. It says for the positive coterminal angle 3 pi over 4, subtract 2 pi to obtain a coterminal angle. So it subtracted 2 pi, gave us a negative coterminal angle of negative 5 pi over 4. How would I find a positive coterminal angle to 3 pi over 4? What would we do? How do we find a positive coterminal angle? Add 2 pi over 1, perfect. So we need a common denominator here. We can multiply the top and the bottom by 4, so we get 8 pi over 4. What's 3 pi plus 8 pi? 11 pi over 4. So this would be our positive coterminal angle. What if it gave us degrees? What if it said, let's go 60 degrees. How would I find a positive coterminal angle for 60 degrees? We're going to talk about converting in a second, but to find a coterminal angle, let's leave it in degrees. What's the equivalent to adding or subtracting 2 pi? 360. So I could add or subtract 360. So if I add 360, I would get 420 degrees. When we subtract 360 to find a negative coterminal angle, what do we get? Negative 300 degrees. So this would be our positive and negative coterminal angle for 60 degrees. So it works both ways. You can find it in radians and degrees. But for radians, you're add or subtracting 2 pi. For degrees, you add or subtract 360. So the next way that we can measure angles is in degrees. So degrees we're a little bit more familiar with. If I said something was 60 degrees, you probably know the length of it a little bit quicker than you would if it were in radians. Here's our quadrants. So we have 0 to 90 would be our first quadrant, 90 to 180 is the second quadrant, 180 to 270, then 270 to 360 is our fourth quadrant. So all the way around, one full revolution is 360 degrees. A half of revolution would be halfway around our circle, so from here to here, which would be 180 degrees. And then a quarter revolution would just be a quarter way around of our circle, so from here to here, which would be 90 degrees. And it says because 2 pi radians corresponds to 1 complete revolution, degrees and radians are related by the equations here. So 360 degrees is 2 pi radians. 180 degrees is pi radians. We can convert from degrees to radians and from radians to degrees. So if we go from degrees to radians, we multiply by pi over 180. And if we go from radians to degrees, we multiply by 180 over pi. This page just has some common degree measures and radians that go with it. But if you don't remember these, you could always just convert them to find out. But these are ones that you'll see pretty often. Let's look at example 2. So we have a degree here. We're going to convert it to radians. What do we do to convert this to radians? We multiply by pi over 180. Perfect. So we get 135 pi over 180. Now we have to simplify our fraction as much as we can. What goes into both 135 and 180? What? 5. Perfect. We can start with 5. So start small. If that's the only thing that you see, divide it and then try again if you need to divide again. How many times does 5 go into 135? 27. Perfect. So 27 pi over, how many times does 5 go into 180? 36. Awesome. Now what goes into both 27 and 36? 9. 3 would be right. 3 does go into both of them, but then you'd still have to divide again. So let's try 9. So 27 divided by 9 would be 3 pi. And then 36 divided by 9 is 4. Can we simplify this anymore? No. So 3 pi over 4 is equivalent to 135 degrees. When we're talking about radians, we don't put any units. It's just implied that it's a radian, so you don't even need to write radians. But if you're talking about degrees, make sure you put the little degree symbol. Not yet. And when converting, I'll probably give you things that aren't on the unit circle. But we will. We'll get into unit circle in the next couple sections. All right, let's look at B. Again, we have degrees. How do we convert from degrees to radians? Multiply by pi over 180. So we have 540 pi over 180. I see that I could divide them both by 10. So I have 54 pi over 18. What goes into both 54 and 18? 9 goes into both of them. So 54 divided by 9 would be 6 pi. And then 18 divided by 9? 2. Can I divide 6 pi by 2? So again, you did this in geometry and in algebra 2. Two positive angles are complementary when their sum is 90 degrees or pi over 2. So complementary means that they add up to 90. And then the radian version of 90 would be pi over 2. Two positive angles are supplementary when their sum is 180 or pi. So 180 is the equivalent to pi in radians. Now, key words here is that they have to be two positive angles. So we cannot have negative angles that are complementary or supplementary. So two positive angles are going to add to 90 for complementary. Two positive angles are going to add up to 180 for supplementary. So they have to be positive. So let's do example 4a. So let's start with complementary. What would I do to find the complementary angle here? Awesome. 90 minus 72, which would give us 18 degrees. Now, when we're writing our answer, when we're talking about degrees, make sure you put the little degrees symbol. How would we find a supplementary angle? 180 minus 72. Perfect. So 180 minus 72 would be what? 108 degrees. Don't forget the degrees symbol. Let's do B. How would we find the complementary angle here? So be careful. Look at what we did in the first one. We did 90 minus the angle and 180 minus the angle. That 90 and the 180 always have to come first. So when I do 90 minus 148, what do we get? A negative number, right? Can we have a negative complementary angle? No. So do we have a complementary? Nope. So there is no complement. We do not have a positive angle that could add to 148 and equal 90. So there is no complementary angle here. Let's find the supplement next. So supplementary angle, what do we do? 180 minus 148. What's 180 minus 148? 32 degrees. Perfect. Let's do the same thing, but now we have radians. So one way that you could do this is you could convert to degrees, but then you'd have to convert back. So let's just keep with what we were doing, but let's do it in radians. So for our complement, what would we do? Perfect. Pi over 2 is the equivalent of 90 degrees. So pi over 2 minus 2 pi over 5. What do we need when we're adding or subtracting with fractions? Common denominator. So here, what would I multiply the first fraction by? 5. So we get 5 pi over 10. What would we have to multiply the second fraction by? 2. So we'd get 4 pi over 10. What's 5 pi minus 4 pi? Just pi over 10. So that would be our complement. Let's find our supplement now. What would we do to find the supplementary angle? Perfect. Pi is the equivalent of 180 degrees. So pi minus our angle, 2 pi over 5. So same thing here, we need a common denominator, so I can make it pi over 1, multiply the top and the bottom by 5. What's 5 pi minus 2 pi? 3 pi over 5, perfect. Let's do D. Let's start with the complement. How would we find our complementary angle here? Pi over 2 minus 4 pi over 5. So we need a common denominator. What could I multiply the first one by? 5. So we get 5 pi over 10. What do we multiply the second one by? 2. So we get 8 pi over 10. What's 5 pi minus 8 pi? Negative 3 pi over 10. Can our complement be negative? So what would our answer be here? No complement. No complementary angle. Has to be positive. What about for our supplementary angle? Pi minus 4 pi over 5. Perfect. So I'm going to make this 5 pi over 5. Give us a common denominator. What's 5 pi minus 4 pi? Pi over 5. So this would be our supplementary angle. Next page, we're going to talk about arc length. So our arc length formula comes from that first formula that we had on the first couple pages when we talked about finding radians. So our arc length is S. S is equal to R times theta, where R is our radius and theta is the central angle. So arc length is S is equal to R times theta. Now, just like before, theta is measured in radians. So when you're using this formula, make sure theta is in radians. So looking at example 5, a circle has a radius of 4 inches. Find the length of the arc intercepted by a central angle of 240 degrees as shown in the figure. So we're going to find the arc length with our formula S is equal to R times theta. So we're looking for S, the arc length. What's our R? What's the radius? 4. Perfect. And what's our theta? Now here it tells us that our theta is 240, but what does theta have to be in? Radians. So it tries to trick you because it tries to think that you're going to just plug in 240, but we know that it has to be in radians. How do I change 240 degrees to radians? Multiply it by pi over 180. Perfect. So we have to convert it to radians first before we can plug it into our arc length formula. So we get 240 pi over 180. We can divide them both by 10. So 24 pi over 18. What goes into both 24 and 18? 6. So 6 goes into 24 4 times. So we got 4 pi on top. And 6 goes into 18 3 times. So 4 pi over 3 would be our radians. Now, once our theta is in radians, we can plug it into our arc length formula. So S is equal to R times theta. So 4 times 4 pi over 3. What's 4 times 4 pi over 3? $16 pi over 3. Remember, make it 4 over 1. When you're multiplying with fractions, just multiply straight across. So 16 pi over 3 would be our answer. This is our arc length.